Hey there, deep diver. Ready for a deep dive into the world of engineering?
Always up for that.
Today, we're taking a look at, well, actually breaking down a student project.
Oh, cool. What's cool?
Bangladesh University of Engineering and Technology.
Impressive.
It is. And it's their work on signal processing that really caught our eye.
Signal processing. One of those things that's everywhere, but we never really think about it.
Totally. Like right now, we're using microphones and all this tech just to have this conversation.
And it magically ends up in everyone's ears.
Yeah, the magic of engineering. But let's get back to this project. We'll be unpacking their project report on system response and filter design. And get this, they even built a MATLAB app to bring it all to life.
Wow, that's going above and beyond, turning theory into something practical. Love to see that.
Right. Okay, so this report is from a course called, get this, Numeric Technique Laboratory.
Sounds intense.
You said it.
Yeah.
Their project zeroes in on system response and filter design.
Okay, so before we get lost in the jargon, could you give us a quick breakdown of what we're actually talking about here?
Of course. Imagine, like, flipping a light switch, right?
Okay, got it.
The light turning on, that's the system's response to you flipping the switch, the input.
So understanding how that response happens is key in electrical engineering.
Exactly. Now bring in filters.
Like Instagram filters for my photos.
Not quite. Think more like adjusting bass and treble on your stereo equalizer.
Oh, okay, I see.
That's filters in action. They allow certain frequencies to pass through while blocking others.
Cool. So in this project, did the students actually, like, build something?
They did. They visualized how systems respond to sudden changes, like our light switch example.
And they used MATLAB for this.
Exactly.
MATLAB, it's like the ultimate engineering toolbox, right?
For real. And here, these students used it not just for analysis, but to build an app anyone can use to grasp these concepts. They really wanted to make something complex, user-friendly.
Now that's impressive. Turning complex engineering into something anyone can explore. I like it.
Right. And they don't shy away from the technical stuff either. The report's got step response, Laplace transform.
Uh-oh. Should I be intimidated?
Not at all. Think of it like this. Imagine trying to rebuild a car engine.
Okay.
But it's completely disassembled, parts everywhere.
Gotcha. A recipe for disaster.
The Laplace transform is like having a set of instructions to put it back together. Simplifies things, makes it easier to see how each part works with the others.
So it's like translating engineer to English.
You got it. Makes it easier to analyze a system's behavior. Then there's step response.
Which is?
Basically a fancy way of saying we're looking at what happens when there's a sudden change.
Ah, like flipping that light switch.
Exactly. They're setting the stage before diving into those filters we talked about.
Speaking of, the report mentioned different types.
Right, it did. Low pass, high pass, band pass, and band stop. Each with their own way of shaping signals.
Okay, I think I'm getting a little lost in the weeds with these filters. Can you give me a real-world example or two?
Sure. Ever used noise-canceling headphones?
All the time, especially on airplanes.
That's your low-pass filter in action, only letting those calming frequencies through.
So like blocking out the crying babies and engine noise.
You got it. Or think of turning up the treble on your stereo, that's high-pass, emphasizing those higher frequencies.
Oh, okay. I'm starting to see how this all connects.
Right. And what's cool is these students didn't just stop at the theory. They actually wrote code to analyze the system's response.
Like actually program something. That's next level.
For real.
Hmm.
They figured out how to analyze a system from both a visual, like a graph, and by plugging in specific values.
Wow. So they've got the theory down, and they're building tools to apply it.
Yep. And their MATLAB app, it wasn't just for show. They designed it to tackle various scenarios, making it super versatile for testing those different filters we discussed.
So like a one-stop shop for all things filters.
Exactly. And they built in some really cool functions, like calculating specific frequencies directly from a graph.
Frequencies, those are what determines where a filter kicks in, right?
You got it. And they could visualize the system's response using that step response concept.
Wow. So it's like they're giving you a window into the inner workings of the system. Very cool.
Right. They didn't stop there. They even made it possible to input custom transfer functions.
Okay, you've lost me. What in the world is a transfer function?
Basically, think of it like a system's mathematical fingerprint.
Okay, that makes a little more sense.
And they didn't just throw this advanced feature in there and hope for the best.
What do you mean?
They actually made it user-friendly, provided guidance, examples, all within the app.
So even if you're not a MATLAB expert.
Exactly. They wanted to make this accessible.
Now that's thinking ahead.
And they took it even further. Users can define their own functions, like a sine wave, and see how the system reacts.
So it's interactive. That's a really cool way to learn.
That was their goal. Make it engaging. They even included examples in the report like at T10 XPT and at T5 cos plus XP.
Wow, they've really thought of everything.
Right. Okay, so we've covered system response, filter types, their super cool app, but there's more.
Seriously, there's more.
Oh, yeah. In their future prospects section, they talk about expanding the app to handle even more complex circuits.
Like what?
They even mention active filters.
Now that's where things get really interesting. So active filters, they're like the cooler, older sibling of those passive filters we discussed.
Okay, cooler in what way?
Well, those passive ones with their resistors, capacitors, and inductors, they're great for the basics, but active filters, they bring in the big guns like transistors and op amps.
Op amps?
Yeah, op amps. They can actually amplify signals. Think of it this way.
Okay.
Using a handsaw versus a power saw. Both get the job done, but
One is way more efficient.
exactly. Active filters, they're like those power tools.
Yeah.
More precision, more control, more possibilities.
So we're talking about a whole new level of what you can do with signal processing.
Absolutely. And their applications are everywhere. Audio processing, medical devices, anything that transmits signals. They even use them in aerospace engineering.
Wow. Okay, so active filters are kind of a big deal, and these students wanted to incorporate them into their app.
That's right. They really wanted their tool to handle even these advanced designs, to be even more, what's the word?
Versatile.
Yeah, versatile, to tackle those really complex engineering problems.
They were already thinking so far ahead. But they didn't just stop at active filters, did they?
Nope, they sure didn't. These students had even bigger plans.
They mentioned building an app that could automatically recognize and analyze any system.
Ambitious.
That's an understatement. Think about the possibilities, though.
They'd be huge.
An engineer could input a system's parameters, and boom, instant insight.
Imagine, no more spending weeks, months maybe, analyzing a system.
It'd be like having, an AI assistant for engineering.
Exactly.
These students, they weren't just satisfied with understanding the theory, they wanted to change how engineering is done.
And that's what's really exciting here, right? Seeing this level of innovation makes you realize these students from Bangladesh University of Engineering and Technology, they're not just the future of engineering.
They're the present.
Absolutely.
Yeah.
And it reminds us that these incredible minds are out there all around the world.
So inspiring. But okay, let's bring it back down to earth for a second. The report does mention they hit some bumps along the way, right?
Oh, for sure.
Yeah.
Even the most ambitious projects have their hiccups.
Right, exactly. They talked about the challenges of extracting info from graphs, dealing with data errors,
Oh, yeah, that data cleaning process can be a real pain.
and then trying to build their own step function in MATLAB. Sounds like a whole other beast.
Yeah, you got to hand it to them. Sounds like they really wrestled with some tough stuff.
Which I guess just makes their accomplishment even more impressive. They didn't let these challenges stop them.
It's like they say, right? You learn more from your failures than your successes.
Yeah, and that's what's so important in any field, right? Learning from those mistakes.
Absolutely. And that's what these students did. They turned those challenges into opportunities for growth and innovation.
It's really inspiring to see that kind of dedication. They had a vision, they hit some roadblocks, but they kept pushing forward.
And let's not forget, they were dealing with some seriously complex stuff. System response, filter design, active filters, even dreaming up an app to analyze any system.
It's mind-blowing. And to think this was all part of a student project, it really makes you wonder, what other groundbreaking ideas are brewing in universities around the world?
Right. These students are just one example of the incredible talent and potential that's out there. It's exciting.
It really is. This deep dive has been a journey, that's for sure. We've gone from those basic engineering concepts
System response, those filters.
to exploring the future of the field, like those active filters and the potential for automated analysis.
And all thanks to the ingenuity of these students from Bangladesh University of Engineering and Technology.
Their project really highlights the power of hands-on learning. They didn't just read about these concepts, they lived them. They built something tangible, something that could change the way we approach engineering.
It's a great reminder that innovation can come from anywhere. And it starts with curiosity, with that desire to learn and explore new possibilities.
And maybe even challenge the status quo a little bit.
Exactly. So to all our deep divers out there, remember, don't be afraid to ask those what-if questions. Dive into those topics that fascinate you. Who knows? You might just spark the next big breakthrough.
Couldn't have said it better myself. That wraps up another deep dive. We'll be back soon with another fascinating look into the world of science and tech.
Until then, keep exploring.
And keep on diving deep.